Hey guys, Mrs. Traver here. We're going to walk through our notes on the systems of equations. So let's pull that up. Let's see. We're going to work through some examples of these guys. I'm going to try to run through one of each of the four different types. So the first one is that of when they're both already solved for y. So if I had like y equals 6x plus 23 and y equals negative 5x minus 10. So when solving the substitution method, our game plan here is to either have x or y already solved for, or solve for it, and then we can set that inside of the other one. So notice these are both solved for y, like I said, so I can put this guy into there, and I'm going to go ahead and do that. So where I see a y, I'm going to put a 6x plus 23. And then on the other side, I've got my negative 5x minus 10. So basically, I just set them equal to each other. From here, I can solve for x. So let's move all the variables to the same side. I'm going to add 5x to both. Over here now, I've got 11x, and dropping down plus 23 equals negative 10. I can move my numbers to the other side now, so move that 23 over by subtracting it. On the left, I've got 11x. On the right, I've got negative 33. Dividing both sides by 11, I've got x equals negative 3. So I've got my first of the two coordinates. And then I just had to go ahead and plug that in to get the other one. I can plug it in for either this x or this x. It does not matter. I'm probably going to just plug it into the first one since I've been using that equation already. So now I'm going to rewrite that as y equals 6, and instead of x, I'll put a negative 3. So y equals 6x plus 23, but x is now negative 3. So we've got y equals negative 18 plus 23. Y equals 5. So I've got both coordinates now, my x and my y. So I can write my final answer. The intersection of these two lines is at negative 3, 5. All right, so that's the first type when they're both solved for y. Let's get another one. What if one of them is solved for y, like this one, y equals 8x minus 7, and the other one is not? Negative 2x minus 7y equals negative 9. So I can't set these equal to each other, but since this one's already solved for y, I can go ahead and put it into that y spot. So I'll just have to end up doing some distributing. So let's do that. I'm going to write it up here. Negative 2x minus 7, and make sure you put a parenthesis. So this whole thing is going in the y. It deserves a parentheses. And then I'll just copy the rest down. From here, let's do some distribution. So I've got negative 7 times 8x is negative 56x. Negative 7 times negative 7 is positive 49. From there, I can do some combining here. Negative 2x minus 56x is negative 57x plus 49 equals negative 9. Move our 49 to the other side. So I've got negative 57x equals negative 9 minus 49 is negative 58. I'm sorry, right here, this should have been a 58. That will make it work out a little nicer. Dividing both sides by negative 58, I've got x equals 1. So I've got the first of my two coordinates. That's always the most work to get. From there, again, I can plug it into either x. I would rather pick the first one because it's already solved for y, and that's what I'm missing. So let's plug our 1 into this spot, and I'll rewrite that. So instead of y equals 8x plus 7, it's going to be y equals 8 times 1 plus 7. So y equals 8 minus 7, or y equals 1. So I've got both my coordinates now, and my final answer is 1, 1. All right, let's look at another one here. This one we'll have both equations not solved for y or x. So we've got 2x plus 10y equals 16, and x plus 5y equals 8. All right, so let's see. Since neither of one of these are solved for x or y, and I want to substitute, I need to get one of them solved for x or y. And looking through, if I had picked this x to solve for, I'd have to eventually divide by 2. If I pick this y to solve for, I'd have to eventually divide by 10. If I pick this y to solve for, I'd have to eventually divide by 5. But this x would be really nice and easy to solve for, because all I have to do is move 5y to the other side. So let's do that. Let's move our 5y to the other side. And now this equation becomes x equals negative 5y plus 8. So now my two original equations are here and here. And I can take this version of x and put it in this spot. So if you're not solved for x or y, then pick one of the x or y's to solve for. It does not matter. Any of the four are fine. Just pick the easiest one. So let's rewrite this guy. 2, and then instead of an x, I'm putting negative 5y plus 8 plus 10y equals 16. I've got distributing to do here. 2 times negative 5y is negative 10y. 2 times 8 is 16. Some combining to do here. Actually, the combining here, those are going to cancel. So I'm left with 16 equals 16, which is a strange place to be in. What we want to think about here is that this is always true. Always true. So for any x or y that I would have put in here, I would have got something that's always true. So it doesn't matter what x and y you plug in, it'll end up to be a true statement. So what that means is that these are the same line. And notice, if we look back at them, if you take this second equation and multiply everything by 2, you get the top. X times 2 is 2x, 5y times 2 is 10x, 8 times 2 is 16. These are actually the same. So these two lines are the situation where we have one and then the other one is right on top of it. So we call that infinitely many solutions. So if you run into a case that's always true, then that should lead you to think that there's infinitely many solutions. We're going to run through one more and then call this a wrap. All right, the last one we're going to look at is this one. It's also got neither x nor y solved for, so we're going to have to do some work to do that. Looking at the coefficients out front, I've got a 2, a 1, a 4, and a 2. This y is going to be the easiest to solve for because it's got a 1 out front. So let's go ahead and do that. I'm going to kind of move it over here to make that happen. So our first thing we would have done is moved our 2x to the other side by subtracting. I'd have negative y equals negative 2x plus 5. And then I would have got rid of that negative by multiplying everything by negative 1. So I've got y equals 2x minus 5. So I've got this equation solved for y now, and I can plug it into that spot. So let's go ahead and do that. I've got 4x minus 2 times the quantity, 2x minus 5 equals 20. We could do some distribution here with the negative 2. So I've got, drop that guy down. Negative 2 times 2x is negative 4x. Negative 2 times negative 5 is positive 10. This piece is going to cancel out, so that's gone. And I'm left with this weird situation, 10 equals 20. So just like the last one, we had to think about this. The last one was always true. This one is always false. So this is a situation where our no matter what x's and y's we put in, we will never come up with a true statement. So these two lines never cross. These are a parallel line situation. So because there's no situation where they cross, there is no solution. Meaning the solution is when we find the intersection. So we've run through quite a few examples here. Oops, that's not the right side. We've ran through quite a few examples here. Where did the paper go? Oh my goodness, here it is. Where starting off, we had both of them solved for y. and we were able to set them equal to each other. If they're not, then you have to get one of them solved for y and plug it in, which we did some work on in the last two as well. And we had examples where there were both one solution that we could name, where there was infinitely many solutions, and as well where there was no solution. So we've got a little bit of everything here. Hopefully that's helping you out for this section. Other than that, I will see you guys next time.